the visualization of data. In your experiment, you always have some kind of measured data. And if you list the data, you cannot see the trend of the data. So the best way is to draw them by curves or by surfaces. So here, I shall explain to you how to do two-dimensional plottings and how to draw implicit functions. It's actually difficult to draw the functions using other languages. And also I will explain to you how to decorate the graphs. Suppose in your experiment you have measured this point T1 and Y1 for a pair of variables T1 and Y1 and T2 and Y2, Tn and Yn. Suppose you have these variables, you have measured this data, or you have through computation or simulation you get some data. How to draw curves or two-dimensional, three-dimensional curves from the data, how to visualize them. What you need to do is to simply create a T vector and then a Y vector. In that case, there are two vectors. And then you can use the plot command, and you can draw the curve directly. I have already demonstrated this part by this curve. It is similar. If you have two vectors of the same size, you can use plot command. For instance, if we want to draw this curve with a given mathematical formula, and x is given in the interval minus pi up to pi, so how can we draw the curve? First, we can generate an x vector, and we can use the column expression to generate an x vector, where 0.05 is the increment. So we can define an x vector. If we have an x vector, we can use this formula to calculate for each value of x the value of y. So this is the command we use. Here, y is also a vector, and since it is based on x vector, it should be of the same size as x. So what we need to do is to draw the curve using plot command. And this is easy. However, how can we check whether this plots are correct or not? It seems that actually this curve is quite strange. And if I zoom this plot, there are several tools we can zoom the plot. We can see that the curve is in fact obtained by joining central points by straight lines. So join them by straight lines. So it seems that these curves are not correct because it should be symmetrical, but these two are obviously not. And there are sudden changes at these points. So how to check it? The easiest way to check it is to change the increment. If we need refine the increment, reduce the size of the increment, so we get more points of x. And then we calculate y again and plot again. We can get another plot. So do not rely on Matlab too much. There are certain things you have to double check when you get the result. And checking the result is easy. For instance, for this example, we can only change the increment. And you get something like this. And at this point, the oscillation is very strong at this point. And why at this point the oscillation is strong? We can see that this one is minus half pi, and this one is half pi. As we recall the original function, we know that when x tends to half pi, then this one tends to infinity. And so the one changes rapidly, even there is a small change in x. So the sign is unpredictable. So it will oscillating very strongly. So to the minus half pi. So at these 2 points, we see that we get strong oscillations apart from this point. The display is not good actually. On my computer is quite good, but the display with this resolution is not good. So it looks like the curve is not smooth. If you change the resolution, because it is done on pixel basis, so it's not quite good. The resolution is 640 by 400. Yeah, this is the way we check it. If we further decrease the size of increment, we get virtually the same result. So we can say that this one is correct. Now let's check the size of x. We can see that there are 48,000 400, so 628,000 points. Okay, lots of points. But using Matlab, you can draw the curve immediately. So we get quite a lot of points. When we can, using plot command, we can easily find the results. So this is the plot command.